Hello, today we are looking at the independent samples t-test, which is one of the parametric test statistic which is used to analyze quantitative data. We start off by looking at the assumptions of the test, which is one, that the observations within each sample must be independent, that is, they are singular. The scores are independent. The second assumption is that the two populations from which the samples are selected must form a normal distribution or approximate a normal distribution. The third assumption is that there must be homogeneity of variance. That is to say, the two populations being compared should have the same or approximate the same variance. We'll look at an example or a case that we are going to use to try to understand the independent samples t-test. Now, the question is that in a study of exam anxiety, two samples of students were tested for anxiety 2 days before the start of exams. The researcher wanted to assess if significant differences exist in terms of how the students respond to exams and whether these differences are based on the level of the student. So the researcher compared part 1 students' scores and part 2 students' scores in terms of anxiety. And they wanted to ascertain if there is a significant difference between these two groups in their anxiety scores using an alpha of 0.05. Now, the first step there is to state the hypothesis. Now, the null hypothesis would be that there is no significant difference in the anxiety scores of part 1 students and part 2 students. The alternate hypothesis would be that there is a significant difference in the anxiety scores of part 1 students and part 2 students. Step number 2 would be to come up with a decision criteria. Now, alpha is 0.05 and it's a two-tailed test. We need to ascertain at which point do we accept or reject the null hypothesis. Let's identify our degrees of freedom first. The degrees of freedom for the independent samples t-test is found by adding the number of participants or subjects in group 1 plus number of participants in group 2 minus 2. So group 1 is with 8 participants, group 2 is with 8 participants, that is 8 plus 8, which gives us 16 minus 2, and that is 14. So our degrees of freedom, or DF, is 14. Our T-crit, or our critical value for the t-test, is plus or minus 2.145. Let's see how we get to plus or minus 2.145. We go to our statistical table, and on the degrees of freedom, it's number 14, which is our degrees of freedom. We look where 14 and the significant value or level, which is 0.05, intersect, and there is 2.145. The intersection of the alpha level and the degrees of freedom on the statistical table will give us the T-crit, or the critical value of the T. So what it means is that when you go to our probability curve of the normal distribution, what it means is that when we get a value which is beyond 2.45 or beyond minus 2.145, we reject the null hypothesis. That is what I've highlighted there as the zone of rejection. Plus 2.145 or minus 2.145, anything exceeding that. Then in between minus 2.145 and plus 2.145, we accept the null hypothesis. That is what I highlighted there as the zone of acceptance. So now we have our decision criteria. We can now go on to calculate the t-test. The first step, we need to identify our formula there for the t, which is t is equals to mean for group 1 minus mean for group 2 over estimated standard error. And we now look at the two groups there, x1 and x2. x1 is representing group 1 and x2 is representing group number 2. So we now have to square all the values for group number 1 and square all the values for group number 2. And then we add. So what we do is then we are adding all the values for x1, which gives a summation of x1, which is 41. We also then have to square all the values in group 1, represented there by x1 squared. For instance, 7 squared, which gives us 49, 6 squared, which gives us 36. And then we add all those values, and it gives us summation of x1 squared, which is 245. We do the same for group number 2, all the values for group number 2, which is represented there as part 2, students' anxiety scores. And they are 2, 5, 4, 3, they up to 8. We add them, they give us summation of x2, which is 30. We also square all those values from our table. You can see we square all those values, and that is 2 squared, which is 4, 5 squared, which is 25, etc. Then we go down, we add all those values, and we get summation of x squared 2, which is 144. After that, we proceed to the next step. In this next step, now we are calculating the sum of scores. We are going to calculate the sum of scores for the two groups. Sum of scores 1, which is SS1, is equals to summation of x squared minus summation of x bracket squared. And there we are, summation of x squared. If you are following, you can also check there. It is 245 from our previous calculation, minus summation of x bracket squared over 8. And summation of x there was 41 squared, which gives us 1681 over 8 now, which is our n. So we are saying 245 minus 1681 over 8. So our summation of x, our summation of scores for group 1 is there, 245 minus 210.125, which gives us 34.75. We do the same for group number 2. We need to calculate the sum of scores for group number 2, which is summation of x squared minus summation of x bracket squared over n. Summation of x squared from our previous calculation there is 144. We check that table, minus summation of x bracket squared, which is 30 squared over 8, which gives us 144 minus 900 over 8, which gives us 144 minus 112.5. So summation of scores for group number 2 of SS2 is 31.5. We now go to the next step in our calculation. There we are. We need to find the mean for the two groups. The mean for group number 1, x power 1, is equals to summation of x over n, which is 41 over 8. So the mean there is 5.125. The mean for group number 2, summation of x over n, again, which is 30 over 8, and that's 3.75. So these means are very important to go, because we're going to be using them when we are going to be substituting our formula. We go to the next step. All right, there we are. We need to calculate the pooled variance. We need to calculate the pooled variance. Pooled variance is equals to summation of scores for group 1 plus summation of scores for group 2 over degrees of freedom for group 1 plus degrees of freedom for group 2. So the summation of scores for group 1 or SS1 is 34.75. We've already calculated that. Plus summation of scores for group 2 is 31.5 over degrees of freedom for group 1 plus degrees of freedom for group 2. Now, degrees of freedom for group 1, we are simply saying n minus 1. Group 1 is 8 minus 1 because there are 8 participants there. So we are saying 8 minus 1, which gives us 7. The same applies for group 2, again, just with 8 participants. So we are saying again 8 minus 1, which gives us 7. So 7 plus 7, substituting our formula for pooled variance. The 66.25 over 14. So our pooled variance is 4.73. We go to the next sub-step. Our next sub-step there. There we are. We now calculate the estimated standard error. Estimated standard error. The estimated standard error is equals to pooled variance for group 1 over pooled variance over N1 plus pooled variance over N2. Now, pooled variance, our pooled variance is 4.73. So we are going to say square root of pooled variance over N1, that is group 1, plus pooled variance over N2. So this gives us square root of 4.73 over 8 plus 4.73 over 8 square root. That gives us square root of 0.59 plus 0.59, which gives us 1.18. So our estimated standard error, estimated SE there, is 1.09. We go on to the next step in our calculations, which is probably the last one there in terms of calculation. We now have to substitute the formula. T is equals to, from our formula, T is equals to x bar 1 minus x bar 2 over estimated standard error. X bar 1 there meaning the mean for group 1 minus the mean for group 2 over estimated standard error. And that gives us 5.125 from the mean that we calculated earlier on, if you still remember. 5.125 minus 3.75 over 1.09, which is our estimated standard error, which gives us 1.375 over 1.09. Our T obtained there is 1.26. So our T obtained is 1.26. Now, when we have done that, we now have to make a conclusion. What does that value mean? We now have to come up with a conclusion. What conclusion do you think we can come up with there? We have to make reference to the secret, which is plus or minus 2.45 that we had calculated earlier on. Now, this is how we can come up with our conclusion. Since our T obtained which is 2.145. Our T obtained, sorry, which is 1.09, falls within the zone of acceptance. Our T obtained, which is 1.26, falls within the zone of acceptance. The researcher will have to accept the null hypothesis and conclude that the two groups do not significantly differ in their anxiety scores. I hope I've made you understand the independent samples t-tests. You can replay the video and try to understand it much better. Thank you for listening.